Hello everyone. Today we will have a look at yet another case study. Now this is called as MELD 3D prints. Okay, it comes under the heavy industry and then it prints a 10 feet dia aluminum cylinder. Let us see how does this happen. Now regarding the company is called as MELD Manufacturing Company and it is situated in Christiansburg um, at Virginia. And actually they hold a lot of patents of trying to do these kind of things which are very unique and cannot be done by any ordinary kind of industry people, right? They have a truly novel and innovative process for metal manufacturing. The traditional process like melt metal, introducing weakness in other issues like melt. This company Melt makes material malleable without melting, offering stronger, better quality parts. Now, introduction to the case study. The case study is about the challenges which has already been told, that is making of a cylinder, an aluminum cylinder, which is of 10 feet dia. The Mel Manufacturing company has commercialized a unique friction consolidating 3D printing process, and they are able to make a 10-foot or 3.05 meter diameter aluminum cylinder using off the shelf aluminum. Any ordinary aluminum, they're able to take it up and then do it. The challenge is the size. Okay, so the size of the component is a milestone for the company and the for the metal additive manufacturing industry as a whole of trying to make such a big metal part. The melt process allows the use of off-the-shelf metals in solid or powder form and creates fully dense parts and operates in an open air environment. Now that is the specialty of this. You see the nozzle coming out here and the metal getting deposited here. Okay, so this entire fixture is which holds or the table that holds the 10 feet dia cylinder is there, you can see, and that rotates, and here again this nozzle also rotates about its axis. Now here you can see how the deposition take place. You can see the the layer of deposition, and all the layers marks one piled up one over the other can be seen. The process can take place in an open atmosphere, right? It accounts to that no special chambers or vacuums are needed. Now that's a great advantage. This flexibility not only means less equipment and cost, but it also increases the scalability and makes and you can make parts bigger, better, faster than the other processes. Now that is what is the challenge that this company is able to take it up and do it. The advantage of this whole thing is that is like unlike any other company, it opens up possibilities of working with materials that were once off the table, and it can even allow customers to work with unweldable metals. Okay, so they don't have a specific kind of thing. Anything which is off the shelf, any kind of material can be melted out, and then they can try and do it. The things even which cannot be used for welding, also those kind of metals also can be used. The combination of material freedom and the scalability make the melt a revolution for a wide range of industries, including aerospace, defense, turbo machinery, and others. Now, this is the one, the process that has been shown there is done out of this additive manufacturing. And here you see the melt tool, and the metal comes out here, and then the deposition takes place here over the substrate. Okay. Now, uh, let us go and look at let us look at the video of this case study video. Yeah. So that's it. Let's have a look at this. Uh, let's see the video here. Okay, I'll just play it out a little. We get a hang of this entire process of making of this 10 feet. Can you see the metal getting deposited here? Okay, that's the fixture. And the tool also rotates in its own direction about its axis. See the part is here. This is taken from the top view, and this is how the cylinder gets built. Okay, so very similar. You may get to know the friction stir welding kind of process and its strength with all this being shown. Okay, so that's it. Thank you very much. We will meet for on another case study. Thank you very much.